You step onto a high-speed train in New York City, grab a coffee, settle into your seat, and close your eyes. Before you know it, you're stepping off in London just a few hours later. No jet lag, no airport security, no turbulence. Just a smooth, futuristic ride beneath the Atlantic Ocean. Instead of staring out at clouds from an airplane window, you're watching the deep blue abyss, teeming with marine life, as your train glides through a marvel of human engineering. It sounds like something out of a sci-fi novel, right? That's because, well, it is. A tunnel connecting the United States and Europe is an idea that has fascinated engineers, travelers, and futurists for decades. The benefits would be enormous: faster travel, increased trade, and a massive reduction in carbon emissions. But no matter how appealing the idea is, it's riddled with challenges so enormous that it remains an impossible dream, at least for now. So why hasn't this happened? And why won't it happen anytime soon? Let's break down the obstacles, the wild proposals, and the far-off future where such a project might just become possible. What would possibly make this Herculean task worth the effort? Well, there are several compelling reasons that make this project intriguing, especially when we look at it through the lens of trade, tourism, and sustainability. One of the most obvious reasons is trade. The United States and Europe are two of the world's largest economic powerhouses, and their trade relationship is massive. According to the Office of the United States Trade Representative, trade in goods and services between the US and the European Union in 2022 exceeded a staggering $1.3 trillion per year. Most of this trade occurs through cargo ships and air freight, both of which have their limitations. Cargo ships are slow and expensive to maintain, while air freight can be costly and often unreliable, especially when weather and logistical issues come into play. A high-speed tunnel running under the Atlantic could completely revolutionize the way goods are transported between these two regions. A system where goods could be shipped at lightning speeds would cut down on both transportation time and costs. It's easy to see how this could significantly boost international trade, benefiting businesses, consumers, and economies on both sides of the Atlantic. The ability to move goods quickly and efficiently across such a great distance would be a game-changer, enhancing global commerce in ways we've never seen before. Then, there's tourism. Every year, 12 million people travel back and forth across the Atlantic, and the vast majority rely on air travel. But flying between Europe and the US comes with its own set of challenges, from delays to turbulence and rising costs. They're expensive, time-consuming, and often subject to delays caused by weather, airport congestion, and other unforeseen circumstances. A high-speed tunnel could transport passengers across the ocean in just a few hours. The ability to book a simple, efficient train ride instead of an expensive flight could make international travel more accessible and less taxing. The tunnel could provide a more predictable, stable, and even cheaper way to travel, opening up more options for tourists and business people alike. What's more, the environmental impact of such a tunnel would be significant. Air travel is one of the leading contributors to global carbon emissions. With increasing concerns about climate change, finding more sustainable travel options has never been more urgent. Planes burn enormous amounts of fuel, and that fuel consumption contributes to the global warming crisis. But if the tunnel were powered by renewable energy, solar, wind, or even tidal, a high-speed train running on clean electricity could revolutionize transatlantic travel, slashing its carbon footprint in the process. All these points make the idea of an Atlantic tunnel sound incredibly promising. The potential benefits are immense. It could revolutionize international trade, make transatlantic travel far more efficient and sustainable, and provide a major boost to environmental efforts. On paper, it seems like a no-brainer, a groundbreaking innovation that could reshape the way we live, work, and travel. But, as we know, big ideas are often easier to dream up than to execute. The idea of digging a tunnel under the Atlantic Ocean comes with a staggering list of challenges that make it, quite frankly, nearly impossible. We'll need to talk about these obstacles, because while the benefits are tantalizing, the reality of constructing such a tunnel involves navigating some massive hurdles. From extreme depth and water pressure to the technical challenges of tunneling through such a vast body of water, There are many aspects of this dream that could quickly turn into a nightmare. Let's dive on into the challenges that would make this project not just difficult, but likely unfeasible. The sheer distance and cost involved in creating a transatlantic tunnel are enough to make anyone question whether it's even remotely possible. Let's break it down and see just how massive this project would be. The Atlantic Ocean is one of the largest bodies of water on Earth, and attempting to tunnel through it is a monumental challenge. The shortest distance between the US and mainland Europe is around 3,000 miles, which already puts the scale of the project into perspective. For comparison, the Channel Tunnel that connects the UK and France at just 31 miles long is a fraction of the distance needed for a transatlantic tunnel. Hailed as a remarkable engineering feat, it pales in comparison to the sheer scale of what crossing the Atlantic would require, at least 100 times longer than any underwater tunnel ever attempted. It's not just about length, though. The ocean floor presents its own set of challenges. The depth of the ocean varies greatly, with some parts plunging as deep as 12,000 feet. That means any tunnel would need to contend with extreme pressure and the technical challenges that come with working at such great depths. The seabed also varies from rocky terrain to soft sediments, each presenting its own difficulties in terms of digging and stabilizing the tunnel. Apart from this, another obstacle is the geopolitical and political complexities involved. Building a tunnel under the Atlantic Ocean would require unprecedented cooperation between countries, including the United States, Canada, the UK, and several European nations. The Atlantic Ocean isn't just a body of water, it's a major boundary between multiple nations, each with its own political agendas, regulatory systems, and priorities. For starters, there's the issue of land rights and sovereignty. The United States and European nations have established maritime borders, and these boundaries would need to be reconsidered when constructing a tunnel that cuts across the ocean. Different countries would need to set aside their individual interests in favor for a common goal, which in itself would be a Herculean task. The political hurdles, funding, maintenance, and profit sharing could spark years, if not decades, of negotiations before a single concrete plan takes shape. Moreover, such a project would raise serious national security concerns. A transatlantic tunnel could serve as a vital link for trade and travel, but it could also become a gateway for smuggling, espionage, and other security threats. Nations would face the challenge of regulating and monitoring the tunnel, likely clashing over control, jurisdiction, and safety protocols. With each country having a vested interest in its operation and security, cooperation would be essential, yet incredibly difficult to achieve. Estimates suggest the cost of such a project could reach almost $20 trillion, which brings us to the financial implications. Even if the political obstacles could be overcome, securing funding for a transatlantic tunnel would require a global effort, with contributions from governments, private investors, and international organizations. But with such a colossal price tag, questions around the economic viability of the project would undoubtedly arise. One of the biggest concerns is the return on investment. While a transatlantic tunnel could, in theory, transport both goods and passengers, the reality is that demand wouldn't justify the cost for decades, if not centuries. The Channel Tunnel, which cost around $21 billion in today's money, faced years of financial struggles and took decades to turn a profit. A project of this scale would likely face even greater economic challenges. A transatlantic tunnel would likely face similar delays in terms of profitability. The ROI might not materialize until well into the future, which means countries and investors would need to make long-term financial commitments, something that's hard to achieve in today's rapidly changing economy. And in a world where technology is advancing at a breakneck pace, there are legitimate concerns about how long such an infrastructure investment would remain relevant. High-speed air travel and even potential advancements in space travel could make a transatlantic tunnel seem outdated before it even gets off the ground. The question arises, would it be worth pouring trillions of dollars into a project that could be rendered obsolete by future technological innovations? The economic gamble would be huge. Beyond the political and financial challenges, the social and cultural impact of a transatlantic tunnel would also be significant. If such a tunnel were ever constructed, it could fundamentally change the way people connect, not just physically, but culturally and economically. Imagine instant travel between continents, commuting from New York to London in just a few hours. While thrilling, such a breakthrough could drastically reshape international relations, migration patterns, and even our daily lives. Such a tunnel could change the global workforce. It would make it easier for people to travel across continents for work, education, and tourism. Companies would be able to hire talent from anywhere, making the workforce truly global. However, this might also result in job displacement as the cost of international travel drops significantly. Smaller industries that rely on regional borders might find themselves competing in a much broader, more intense global market. On the flip side, such a breakthrough could redefine how we perceive cities and nations. If crossing the Atlantic becomes as effortless as a train ride, the geographical boundaries that have shaped cultural and political identities for centuries might start to fade. Cities like New York and London might become even more interconnected, leading to greater economic and cultural integration. But it also raises the question, would this result in the loss of individual national identities or lead to a more homogenized global culture? Additionally, the environmental impacts of such a project could be substantial. While the tunnel might initially seem like a cleaner alternative to air travel, the carbon footprint of constructing and maintaining a transatlantic tunnel would be enormous. Mining and tunneling on such a massive scale would release significant amounts of carbon dioxide and other greenhouse gases into the atmosphere. Could the environmental cost of the project outweigh the potential benefits? While we're on the topic of the environment, it's essential to consider the ecological effects of a transatlantic tunnel. While the idea of reducing carbon emissions from air travel is an appealing one, building a tunnel under the Atlantic Ocean would come with its own set of environmental risks. The construction would likely disturb marine ecosystems in unprecedented ways. The process of digging through the seabed could disrupt fish populations, undersea plants, and even fragile coral reefs. Not only that, but the operation of the tunnel would require a significant amount of energy. Trains, ventilation systems, and other infrastructure would need power, and the tunnel itself would have to be constantly monitored and maintained. While it's possible that renewable energy could be used to power the tunnel, it's unlikely that a project of this scale could be entirely green. The long-term ecological impacts are hard to predict, but they could be considerable. Assuming an unlimited budget, could we even construct a tunnel like this? The short answer is probably not. The first and most daunting challenge is the sheer depth of the Atlantic Ocean. With an average depth of around 12,000 feet, constructing a tunnel there would be like building at the height of Mount Everest, only deep underwater. Even more staggering, certain parts of the ocean, like the Puerto Rico Trench, can reach depths of 28,000 feet. These kinds of depths are far beyond the reaches of current tunnel construction technology. But why is depth such a critical issue? It's not just about digging a hole, it's about the immense pressure at those depths. As you descend into the ocean, the weight of the water above creates crushing pressures. For context, at 12,000 feet, the pressure is around 5,400 pounds per square inch. That's roughly 350 times the atmospheric pressure at sea level. To put it simply, anything we currently use for construction, such as steel and concrete, would be crushed or destroyed by such intense forces. We would need materials that could withstand these enormous pressures, yet no material on the market today can handle these conditions over the long term. So, what materials would be required to build a tunnel at such depths? The unfortunate answer is that we simply don't know yet. There would need to be significant breakthroughs in material science to develop materials that can handle the crushing pressure and harsh underwater conditions. Traditional materials like steel and concrete would fail under this pressure. While newer alloys might be stronger, they still haven't been tested in such extreme conditions. Building such a tunnel would require us to rethink not only construction techniques, but the very materials we use to create these structures. One potential solution could involve developing new composites that could better endure such intense pressures. Some scientists have proposed materials like carbon nanotubes, which are incredibly strong and lightweight. However, even these have limitations, especially when faced with underwater corrosion and the constant motion of the ocean. If dealing with the crushing depths wasn't enough, the ocean floor itself presents its own set of challenges. While the English Channel Tunnel had a relatively flat seafloor to work with, the Atlantic Ocean is a completely different beast. Its floor is not smooth and flat, but jagged and uneven, with massive underwater mountain ranges and deep trenches. The topography is more akin to trying to dig through the Rocky Mountains than a flat landscape. The ocean floor is also not made of a uniform material. While parts of it are solid rock, others are soft, unstable sediments that are prone to shifting. Traditional tunneling methods, like those used in land-based tunnel construction, may not work here. Drilling or boring through these materials could be incredibly difficult and unpredictable. We would likely need to invent new tunneling technologies that have never been tested before. Technology that would need to withstand not just the geological conditions, but the dynamic, ever-changing nature of the ocean floor. Additionally, the Atlantic is a region of intense tectonic activity. The ocean sits at the convergence of several tectonic plates, and earthquakes are a real threat. In some places, the plates shift rapidly, causing massive underwater movements. This could make any tunnel we build prone to damage from earthquakes, shifting sediments, and even underwater landslides, not to mention massive underwater volcanoes as well. Keeping a tunnel intact in such a volatile environment would require cutting-edge technologies yet to be developed that could handle these dynamic forces. Let's now dive into the danger posed by seismic activity and ocean currents. The Atlantic Ocean lies along the boundary of several tectonic plates, and as a result, seismic activity in the region is pretty common. Areas like the Mid-Atlantic Ridge are home to active fault lines that regularly shift. Earthquakes could shake the tunnel's structure, causing fractures, shifting it out of alignment, or even destroying entire sections. Even if we could build a tunnel resilient enough to withstand the tremors of a moderate earthquake, there's another massive problem: ocean currents. Ocean currents are incredibly powerful and can change direction or strength unexpectedly. These shifting currents could erode the tunnel structure over time. Corrosion from saltwater and erosion caused by these currents could cause the tunnel to slowly degrade. Maintaining the tunnel to ensure its structural integrity would be an ongoing challenge, and a major catastrophe could be waiting in the wings if natural forces ever act on the tunnel. The more extreme the conditions, the more vulnerable the tunnel becomes. A small failure in one section could lead to a cascade of damage that may be impossible to repair. Sending maintenance crews thousands of feet below the surface would be incredibly difficult and risky. Any failure could trap them miles under the ocean, making rescue efforts next to impossible. Then there's the logistical nightmare of maintaining a transatlantic tunnel. The Channel Tunnel is already a difficult tunnel to maintain, despite being located in relatively shallow waters. Any underwater tunnel requires regular inspections to check for cracks, corrosion, or any signs of weakness. Today, this maintenance is carried out by specialized teams using remotely operated vehicles or divers. But imagine doing this at depths of over 10,000 feet. The cost, complexity, and risks involved would be astronomical. To maintain a tunnel in such a harsh environment, we would need to deploy deep-sea robots, equipped with the latest technology and capable of navigating the tunnel and performing repairs. These robots would have to withstand the immense pressure, operate in low-light conditions, and communicate effectively with surface crews. The risk of malfunction would be high, and the consequences would be disastrous. If a crack appeared in the tunnel, it could take months or even years to make the necessary repairs. Flooding could become a serious concern, especially given the vastness of the ocean and the difficulty of detecting leaks or small structural failures. A malfunctioning section of the tunnel could cause a flood of water that would be almost impossible to fix in time. Even if we could overcome the geological, natural, and logistical challenges, there's one more hurdle: the cost. Developing the necessary technology and materials for such a project would cost billions, if not trillions, of dollars. Tunnel boring machines are designed for relatively shallow constructions, and they would need to be completely re-engineered to handle the extreme depths of the Atlantic. The cost of developing new materials, robotics, and other technologies would dwarf the cost of building the tunnel itself. And once the tunnel was built, maintaining it would require ongoing investments in technology and personnel. Given the challenges, it's clear that no matter how much money you throw at the project, the cost and complexity would far outweigh the potential benefits. Even if the tunnel was constructed, we would still have to ask the question, would it even be sustainable? Air travel continues to improve, and faster trains are already in the works that could one day make transatlantic tunnels obsolete. The staggering costs of building and maintaining such a structure would likely never be recovered, and there's no guarantee that demand would ever justify its construction. From an environmental perspective, the ecological impact of such a massive construction project would be immense. Extracting materials from the ocean floor and the immense energy required to maintain the tunnel could have severe environmental consequences. With such overwhelming costs, risks, and challenges, it's clear why a transatlantic tunnel may forever remain just a dream. Yet despite these overwhelming challenges, some bold thinkers have come up with creative ideas for making a transatlantic tunnel possible. Here are a few of the wildest proposals. One suggestion is a floating tunnel. This isn't your average bridge or tunnel, but rather an idea where the tunnel would float on the ocean, supported by giant pontoons or anchored to the seabed. In theory, it would avoid the pressure and geological challenges faced by traditional tunnels at extreme depths. Also, you don't have to worry about digging through the earth or rock at the bottom of the ocean. The idea of a floating structure being held in place over a massive stretch of water without it being dragged by currents seems unrealistic. Even with advanced technology, the tunnel would be subjected to forces from wind, waves, and storms, making it a sitting duck for natural disasters. Then there's the issue of corrosion. Salt water doesn't just sit there looking pretty. It eats away at metal. No matter how durable the pontoons are, over time they would erode, weakening the entire structure. Not to mention the wear and tear from constantly moving with the waves. The floating tunnel would need to be constantly repaired, and that doesn't sound like a sustainable solution for the long term. Next up is the more familiar idea of a traditional seafloor tunnel. In this proposal, engineers would tunnel deep into the ocean bed, carving through rock and sediment to create a stable pathway for cars, trains, and other forms of transportation. Sounds simple enough on paper, but the challenges are insane. A tunnel boring machine would face the most extreme conditions, and we're talking about a project that could stretch thousands of miles under some of the most challenging underwater terrains. TBMs are good at digging through softer material, but solid rock at the bottom of the ocean? That's a whole different story. The deeper the tunnel goes, the more specialized and expensive the equipment required. This would make the project not only astronomically expensive, but also incredibly slow and inefficient. Then there would be the maintenance costs of keeping the tunnel operational. Now let's shift over to something a little more futuristic. The Hyperloop, a vacuum-sealed tube extending all the way across the Atlantic Ocean. High-speed pods would travel at speeds up to 700 miles an hour, allowing you to go from New York to London in just about an hour. It's the stuff of science fiction, but for a time, it was also considered a real possibility. While the Hyperloop has seen some success on land in small-scale trials, the idea of scaling it up to span the Atlantic is simply mind-boggling. First off, maintaining a vacuum-sealed tube for thousands of miles across open ocean is not only technologically challenging, it's downright impossible with current engineering methods. For the Hyperloop to function, the tube needs to stay sealed. One tiny breach and the whole system could collapse. There's also the whole issue of pressure. Building a vacuum-sealed tube at that depth would cause it to collapse, not to mention the forces of constant shifting water currents. If the tube were placed too shallow, it would be exposed to ocean storms and hurricanes that could rip it apart. Also, the maintenance required to keep such a delicate system in perfect working condition Tracking down leaks, repairing any damage, and ensuring that the system stays airtight over thousands of miles would be virtually impossible. Even though the idea of crossing the Atlantic at lightning speed sounds incredible, the cost of building such a system would be out of this world. Add to that the maintenance costs, and it becomes clear that the Hyperloop across the ocean is more of a pipe dream than a feasible future. So why won't any of these ideas work? Well, it all boils down to a few key reasons: scale, environment, and cost. First, the scale of these projects is enormous. A transatlantic tunnel, Hyperloop, or floating tunnel would stretch across thousands of miles of open ocean, presenting logistical and engineering challenges on a scale that we've never seen before. Creating and maintaining a structure of this size requires cutting-edge technology, vast resources, and an insane amount of manpower. And that's just for the construction. After it's built, maintaining it would require near-constant oversight and repairs. Second, the environment presents a host of problems. The ocean is constantly shifting. Currents, storms, earthquakes, and even minor changes in temperature can all affect the stability of a structure in the water. Saltwater corrosion is a constant threat, and even the toughest materials will wear down over time. A tunnel, Hyperloop, or floating structure would be at constant risk from these forces, and no matter how advanced the technology, it would be difficult to keep things running smoothly. Even with unlimited resources, the sheer financial burden of these projects would be unimaginable. The technology required is currently non-existent, and the ongoing costs for maintenance and repairs would drain any budget in no time. Simply put, these ideas are too expensive, too complicated, and just too risky to be feasible. In the distant future, it's possible that advancements in technology could make a transatlantic tunnel a reality. Innovations in AI-driven construction and ultra-strong materials could allow for the creation of structures that withstand the extreme conditions of the ocean. AI might be able to manage the complex task of digging through the ocean floor, while new materials could handle the pressure and forces deep underwater. But we're not there yet. Today, the ocean floor remains an incredibly challenging and dangerous environment for any construction. Even the most advanced materials and machines would struggle to cope with the immense depth and complexity of such a project. So, for now, the fastest and most reliable way to cross the Atlantic is still by plane. Even with rapid advancements in technology, a transatlantic tunnel is more science fiction than reality. It would require billions of dollars and decades of development, if not centuries. Until teleportation becomes a thing, a transatlantic tunnel will likely remain a distant dream. Airplanes will continue to be our best bet for crossing the Atlantic quickly, with the promise of a tunnel only being a possibility in the far, far future. Thanks for joining me today. I hope you enjoyed the video, and if you want to see more videos like this, then please consider subscribing and turn on notifications. Really does make a difference. Thanks again, and I'll see you next time on MatPack.